Imagine looking on the horizon and witnessing a sunrise that occupies half the sky. NASA has released images of a never-before-seen phenomenon where a star named Betelgeuse blew its top off, ejecting a gigantic portion of its surface mass. The event is known as a surface mass ejection, SME, and according to the Space Agency, the ejection was 400 billion times the mass of an ordinary solar flare from our Sun. Scientists describe the event as watching stellar evolution in real time, with a star blasting off such huge chunks of its physical form, surprising many. The catastrophic explosion of this super-red giant is upsetting much of what we know about the universe. Why did Betelgeuse blow off its top, and how will that affect the universe? Let's find out. Constellations are made up of many stars and are arranged in accordance with mythology and legends. They are still used for navigation today. One such star is Betelgeuse, which is among the largest and brightest stars in our night sky. The brilliant, ruby-red, glittering star known as Betelgeuse is located in the upper right shoulder of the winter constellation Orion the Hunter. When viewed attentively, though, astronomers recognize it is a seething monster with a 400-day-long heartbeat of regular pulsations. Because of its dismal orange-red color, Betelgeuse is easily identified. It's ideal for convincing doubters that stars do, in fact, have different colors. It is also known as Alpha Orionis and is the second brightest star in the constellation, after the blue supergiant Rigel. Betelgeuse is an intriguing object for star studies and observations due to its variable nature as well as its odd name. Frequently, stars with the name Alpha are the brightest stars in their constellations. Even though Rigel, Orion's other bright star, is brighter, Betelgeuse is Alpha Orionis due to its name, brightness, size, and reddish hue. It is also one of the most well-known stars. It's noteworthy that this star served as the model for both the character and the movie Betelgeuse. Betelgeuse is the seventh brightest star visible from most of North America, Europe, and Canada, and it is the 10th brightest star overall in the sky. Earth is relatively close to Betelgeuse. Astronomers are unable to pinpoint Betelgeuse's exact distance from Earth, although they believe it to be between 430 and 724 light-years away. Betelgeuse is the brightest red supergiant star and is closest to Earth in our galaxy. There are just 200 red supergiant stars that have been identified. The Sun has a radius that is around 764 times larger than Betelgeuse's. If this star replaced our Sun in the solar system, it would reach past the asteroid belt and even beyond Jupiter. This suggests that Earth, Mars, Venus, and Mercury would all be completely absorbed. Betelgeuse is 16,128 times as massive as the Sun. This supergiant has 126,000 solar luminosities and is visible from 548 light-years away. This star has a surface temperature of about 3,600 Kelvin, making it cooler than the Sun. Only about 13.3% of Betelgeuse's radiant energy is visible light. If human eyes could see light at all wavelengths, Betelgeuse would overtake Sirius as the brightest star in our night sky. Betelgeuse loses about one solar mass every 10,000 years. The red star is surrounded by a nebula because this material is being ejected unevenly from the star in all directions. A cloud of material 250 times larger than the star surrounds Betelgeuse. The size of this nebula is also thought to be 30 astronomical units, or 30 times the solar distance. The Sun and Neptune, the furthest planet in the solar system, are separated by this distance. Our solar system's Sun regularly ejects mass into space, which is known as solar flares. However, the Sun only exhales tiny fragments of its outer atmosphere, known as the corona, giving the phenomenon the name coronal mass ejection, CME. As a result, coronal mass ejections and surface mass ejections can occur at separate times. When a star ejects a portion of its unstable outer atmosphere, it causes a CME, known as the corona CME. Coronal mass ejections from our solar system occur very frequently and can have an impact on Earth and its inhabitants. CMEs can travel more than 1,800 kilometers per second while ejecting magnetic fields and plasma into space, which allows them to occasionally arrive on Earth in a matter of hours. A CME can disrupt and harm Earth satellites and power infrastructures when it occurs on the side of the Sun that faces the planet, and it occasionally puts astronauts in orbit in danger. The recent discovery sheds light on the exceptional cause of Betelgeuse's stemming into 2019. The material that the star ejected exploded into space, cooled, and produced a cloud of cosmic dust that hid Betelgeuse's brightness from Earth-based observers. Additionally, Betelgeuse's renowned steady pulsing pattern has been altered. The SME on Betelgeuse is unusual because it released 400 billion times more mass than a typical CME, which caused the star to tremble like a dish of gelatin desserts, according to a NASA news release. According to Andrea Dupree, an astronomer at the Center for Astrophysics, the star's internal convection cells may be in disorder while the photosphere, which is what we perceive as the star's surface, struggles to reconstruct itself. Astronomers have been tracking the star's constant pattern for the past 200 years, yet it no longer exists. All red giants, including Betelgeuse, are perishing, and being able to observe this process will allow researchers to learn a lot about the evolution of stars. The majority of stars in the cosmos are powered by nuclear fusion, which eventually burns out and causes a star to undergo a series of intriguing stellar changes before it finally perishes. When a star is born, it is made of hydrogen, which under the force of gravity fuses together in the star's core to create helium. In a nuclear explosion, a lot of heat and light energy is typically released during the fusion process. This energy travels to the star surface and is released as a photon into space. As the star ages, its primary fuel, hydrogen, runs out, and helium starts to combine with carbon to form carbon. After the helium is used up, neon will eventually combine with carbon to form iron. When this happens, the fusion of neon with iron absorbs energy instead of releasing it. Because there is nothing to oppose the star's very powerful gravity when iron begins to fuse, the star collapses in on itself, giving rise to a supernova explosion. A supernova, one of nature's most powerful forces, can generate more energy than 10 billion suns. Stars change hue during the course of their existence, from the youngest, hottest blue forms to the older, cooler red varieties, depending on what stage of their stellar evolution they have reached. The Greek scientist Ptolemy, in 168 AD, strangely referred to Betelgeuse's color as having a ruddy hue. 3 centuries earlier, Chinese astronomers had characterized the star as having a yellow appearance, possibly implying that Betelgeuse was formerly a yellow supergiant. Larger stars frequently burn through their hydrogen faster and die off sooner. Despite being only roughly 10 million years old, Betelgeuse is certainly nearing the end of its lifespan. Our Sun, on the other hand, is still in its prime at approximately 5 billion years old. Furthermore, because Betelgeuse is nearing the end of its life, it's possible that a supernova will occur soon. Betelgeuse undergoes 2 dimming and brightening cycles, the second of which occurs approximately every 5 years and lasts approximately 100 days. The star's outer shell is thought to expand and contract during this cycle, changing the star's circumference and average temperature in accordance with each step of the cycle. Astronomers may gain a better understanding of how red stars lose mass in their last days before exploding in a bright supernova from Betelgeuse's explosion. As Dupree notes, we've never seen a huge mass ejection on the surface of a star before. We are left with something going on that we don't completely understand. It's a totally new phenomenon that we can observe directly and resolve surface details with Hubble. We're watching stellar evolution in real time, but it's unclear whether this development portends Betelgeuse's impending supernova explosion. Because the results are so unusual, NASA issues a warning that Betelgeuse may not have reached the end of its life, even if it is nearing the end. Cosmic time is long, and red supergiants die quickly by comparison. According to NASA, Betelgeuse will explode in the next 100,000 years. Betelgeuse has been the focus of intense study since the 1st century BC. More recently, a scientist by the name of Serena Nance and her team sought to ascertain the potential timing of the supernova explosions of red supergiants like Betelgeuse. To find out how a star that large would behave over time, Nance and her team ran multiple simulations using Betelgeuse as a model. They then contrasted their findings with field observations. Why did Betelgeuse diminish suddenly and out of sync with its regular cycle when it won't likely explode for another 100,000 years? Betelgeuse was evicted from its home in the Orion OB1 association, which comprises the stars in Orion's belt, and has been seen moving through the interstellar medium at a speed of more than 4 light-years. By mid-February 2020, Betelgeuse had lost to found 3 times as much brightness, from magnitude 0.5 to magnitude 1.7, after beginning to decline sharply in October 2019. By February 17, 2020, Betelgeuse's brightness had been stable for almost 10 days, and the star had started to brighten once more. However, Betelgeuse appeared to have stopped dimming completely 5 days later, effectively ending the dimming episode. Given that there were no significant changes in the infrared on February 24, 2020, it appeared that the recent visual fading was unrelated to the anticipated core collapse. Another study concluded that the star's dimming was most likely caused by a cloud of large-grained circumstellar dust. Dust absorption is ruled out from having a significant effect in a study that uses measurements at submillimeter wavelengths, but the fading appears to be caused by large star spots. Further analysis showed a dramatic rise in Betelgeuse's brightness between May and August. Betelgeuse is so close to the Sun that it is almost impossible to see from Earth before 2020, when Betelgeuse will be in conjunction with the Sun. It was +Z point for brilliance, according to the observations made with the Stereo A satellite in June and July of 2020. The star had faded by 0.5 since its previous ground-based observation in April. Everyone was surprised by this because the maximum and subsequent minimum were expected to occur in August-September 2020 and around April 2021, respectively. Betelgeuse's brilliance was known to shift widely, making predictions difficult. The fading seems to indicate that a second dimming event may occur much sooner than expected. The finding of a second dust cloud coming from Betelgeuse, which was linked in June 2020, suggested that a cool patch on its photosphere might be the cause of the dust. In August, a second independent investigation confirmed the initial hypothesis. The dust is thought to have been created by the gas that the star had spilled. According to studies done in 2022 using the Hubble Space Telescope, a clouding dust may have been created by a surface mass ejection. The material was ejected from the star's surface millions of kilometers away, where it cooled, compacted, and formed the star's fading dust. The broken photosphere, which was roughly several times as heavy as our Moon, went off into space, cooled, and created a dust cloud that covered the star from the perspective of watchers on Earth. The fading, which began in late 2019 and continued for a few months, was plainly discernible even by backyard observers who observed the star's brightness change. Even more remarkable, the 400-day pulsation rate of the supergiant has vanished. Since around 200 years ago, astronomers have been tracking this cycle by analyzing changes in Betelgeuse's surface motions and brightness variations. Its disturbance reveals the extent of the blast. Astronomers have now developed a potential theory to account for the disruption. The star is also slowly but surely rebuilding strength, and the photosphere is regenerating. The star's normal cycle is being thrown off, and the interior is vibrating like a bell that has been slammed. A massive stellar surface mass ejection has never before been observed. There is still something going on that we don't fully comprehend. We may directly observe this brand new phenomenon and use Hubble to discern surface features, real-time observation of the development of stars. When will it occur? Probably not in our lifetimes, but in fact, no one really knows. It could be tomorrow or 1,000,000 years from now. Will Earth be destroyed by the Betelgeuse supernova? No, the explosion of Betelgeuse won't affect or partially end life on Earth because it will occur too distant from the planet. Astronomers estimate that for a supernova to be dangerous to humans, we would need to be 50 light-years distant from it. Also, Betelgeuse is over 10 times further away. Instead, everybody on Earth at the same time will be treated to an extraordinarily breathtaking view of a very, very bright star in the night sky. Finally, because of Betelgeuse's vicinity, astronomers will be able to study the star when it undergoes a supernova. Betelgeuse is not now visible in the night sky, so don't go looking for it there. Even if it went supernova right now, we wouldn't see much of it except it is in the midday sky during August. Betelgeuse might have already gone supernova over 5 to 29 years ago, and we haven't yet seen its light. Scientists are excited about the chance to view Betelgeuse's epic eruption and recuperation. In the interim, the James Webb Space Telescope of NASA may be able to track the ejected Betelgeuse material as it travels across space while the Hubble telescope continues to study the star. Thanks for watching another episode. While you're still here, make sure to click the video on your screen for more mind-blowing videos about space.